All right. So we are now looking at lesson 6, grade and pitch, which starts on page 21 in your student handbook. So first we're starting with this idea of grade. And grade is used to talk about steepness of hills and roads. So as you can see, we've got a truck driving down there. So we want to think about why that would be important. Clearly, there's certain things, if you've got a really heavy load on a truck, you don't want to be going down too steep a hill because you can have issues with your load. Certain things like we talked about wheelchair ramps, they have to be below a certain grade, because if they're too steep, someone in a wheelchair is not going to be able to get up them. Even a motorized one, it might be too steep for the motor to push them up. And similarly, if something is too steep for certain vehicles, hauling a heavy load, or say you're riding a bike, you don't want to be going up a grade that is too steep. So what this means that the grade is 7%. And what that means is that, remember, percentage is always out of 100. Right? So if you get 7% in a course, the most you could have got was 100. So you get 7 out of 100. Hopefully that doesn't happen to anyone in this class. So in this case, what this means is that the road drops 7 units vertically for every 100 units, because it's out of 100. When you see that percentage sign, think 100. Okay? Now, how would we turn this slope back into a decimal? Well, we represent a decimal. Percentage decimal is always going to be 0.07. We always do it out of hundredths, and this is the same as having 7 out of 100. And that helps us answer our next question. How would we write this as a fraction? Well, remember, it's always out of 100, so it would be 7 out of 100. So the decimal would be 0.07, and the fraction 7 out of 100. Sometimes it's easier to write it in a fraction and then divide, because if you do 7 divided by 100, you're going to get that decimal answer. Okay, so as long as you remember that it's out of 100 and then go from there, you should be able to get what you're looking for. Okay, so show distances on the diagram below of what could be represented, or what could represent a slope of 7%. So we can stick with our 7 and 100s. This would be 100 meters, and that would be 7 meters. There's other numbers that would work, but those are the simplest, right? Because our slope equals our rise over run, which in this case is 7 over 100, which is 0.07. And if we take 0.07 and we times it by 100%, we're going to get our 7% back. Okay? So if you're given that distance, you can figure it out that way. Now, sometimes we use the term pitch. And this is when the slope is represented by a ratio. Okay? So instead of representing it as a decimal or a fraction or a percentage, we do a ratio. So a ratio would be represented like so: 7 and then a colon and 100. So that's the ratio of the rise to the run. Okay? So if we're talking about pitch, we're talking about the ratio. Check your understanding. So let's see. We just talked about 2 other terms we could use for slope. The first one we learned was grade And the second one we learned was pitch. Okay, and if we think about this, we could do grade as a percentage, a fraction, or a decimal. And pitch was represented by a ratio. The next says, convert the following slopes to pitch and percent grade. Okay, so this slope at 1 over 4, if I'm going to do it as a pitch, it's going to be 1 to 4. That's my ratio, right? Okay, and just want to see here. And if I want to represent that as a grade, I'm going to go 1 over 4, and I'm going to get a decimal, which is 0.25, right? And then I'm going to take that decimal, 0.25, and I'm going to times it by 100%, which, because I want percent grade. So that's going to be 25% for my grade. Okay, the next one, and I'll give myself a little more room. For pitch, it's a ratio. So it will be 2 to 7. For grade, I have my fraction, 2 over 7, and I divide. And when I go 2 divided by 7, I get 0.2857 dot. So I'm going to take that decimal, 28757, times it by 100%, and I get 28.57%. I'm going by the 2 decimal place rule. Often questions will tell you how many decimal places. Now, if I have a slope of slope of 2, remember that's the same as 2 over 1. Okay? It's just divided through, and we gave me a slope of 2. So for pitch, it's a ratio, and it'll be 2 to 1. For grade, I'm going to go 2 divided by 1, which is 2. And then I take the 2 times 100%, and I'm going to get 200%. So that's going to be a very, very steep grade. Okay? Means that for every 2 units, or for every 1 unit I go over, I go up 2. So I'm increasing dramatically. Okay? You're not going to find any roads at 200%. All right? Now you may notice that all of these are positive. When we're talking about roads and hills and that sort of thing, we're going to be talking about it in terms of up and down. And generally speaking, you're going to talk about it in terms of up. Okay? So let's do some examples with questions. It says here, a local business has decided to build a real wheelchair ramp. So that it is more accessible to its customers with disabilities. Canadian regulations require that all wheelchair ramps have a maximum slope of 1 to 12. So what are they giving here? They're giving a ratio. So a ratio would be the pitch, okay? And it wants to know what would be the percent grade of a 1 to 12 ramp. Well, remember, for grade, we're going to write that as a fraction. So we're going to get 1 divided by 12, and we'll get 0.0833 repeating. So we take that 0.0833 repeating, and we times it by 100% to get the percent grade. So we times by 100, and we get 8.33%. And we have to keep that percent in because we're looking for the percent grade. Okay, so we're given the pitch, we found the grade. If the height of the entrance is 0.25 feet, how long will the ramp need to be? So now we need to remember our cross multiplying and divide from the other day. So let's draw a picture so we have an idea what's going on. Here's our ramp, not drawn to scale. If the height is 2.5 feet, and we know from our information here that the slope is 1/12, right? We know that this is equal to the rise over the run. We know that we're looking for how long it's going to be. This is our run. And our height is our rise. So we're going to put in what we know into this equation. Okay, so we have 1/12 is equal to 2.5 over the run. Now we're going to cross multiply and divide. So we cross multiply the 12 times 2.5 and we divide by 1. So x will equal 12 times 2.5, right? We'll draw it a little, okay? And then we divide it by 1. When we do that, 12 times 2.5 and divide that by 1, we get 30 feet. So to go up 2.5 feet on your wheelchair ramp, you have to have 30 feet of ramp. So that's going to be quite a long distance. We really don't want to have a severe pitch or grade for wheelchair ramps. Okay, let's do another example. Here we have a roof. It says an asymmetrical roof has a left side pitch of 3 to 12 and a right side pitch of 4 to 12 and a height of 7 feet. So let's convert our pitches to fractions, to our slope. So here that means the slope is equal to 3/12. And here the slope is equal to 4/12. Okay? Now it wants us first to calculate the percent grade of the left side and the right side. So this is my left side and this is my right side. So left side, I'm going to take my fraction, 3/12, and I'm going to divide. So 3 divided by 12, and I get 0.25. Then I take my 0.25 and I times it by 100%, and I get 25%. So that's my percent grade of the left side. On the right side, I take my slope, 4/12, and I divide. So I do 4 divided by 12, and I get 0.3333 repeating. Okay, I'm going to take that value, times it by 100%. I'm going to stick to the 2 decimal place rule, and I'll get 33.33%. So that would be my percent grade for the right side. Now what it wants me to do is figure out the run of the left side of the roof. So I'm looking for that red X. And I'm going to keep it a red X right now because later I'm going to have to find a blue X. So again, we're going to use our cross multiplying and dividing. I know my slope is 3/12, which is the rise over the run. Okay, now looking at the diagram, the rise is 7 feet. So my rise equals 7 feet. So what I do is I put all what I know into my formula. So I have, and my run, is the red X. So 3/12 is equal to 7 feet over X. Now I'm going to cross multiply and divide by 3. So what that tells me is X will equal 7 times 12 divided by 3, which is 7 times 12 equals, 7 times 12 is 84, divided by 3 is 28. and it's going to be in feet because the units will have to be the same. So for this answer, I get 28. Okay, so it's really just using that cross multiplying and dividing to kind of solve for those things. Now it wants the run of the right side of the roof. So we did our left side. Now we're going to do the run of the right side. Okay, so now just to differentiate, I'm going to make it a blue X. So we know we're talking about a different one. Okay, so let's see what we know. Slope is, for the right side, 4 over 12. And that's the rise over the run. The rise is still 7 feet, right? If we look at our diagram, the rise for both of them is 7 feet. So that equals the blue rise as well, okay? Because they meet in the middle. And my run equals X, and it's the blue X this time. So I have 4 over 12 is equal to 7 feet over X. I'm going to cross multiply and divide by 4. Okay, so let's set that up. So I'm going to have X is equal to 7 times 12 divided by 4. So let's do that. 7 times 12 divided by 4. Again, I put in the wrong thing. 7 times 12 is 84. Divided by 4 is 21 feet. So the run of the right side is 21 feet. Now it says calculate the total width of the roof. Well, if I look, the total width is going to be the left side run plus the right side run. So we're just going to take our 28 feet plus our 21 feet, and that will get us our total distance. 28 plus 21 is 49 feet. And that is the total width of the roof. So sometimes it's just breaking down what we know and what we're looking for. Okay? Now, next few pages are a bit of a review, practicing with what we've learned over the last few days, where we don't have an exit slip today. So you're going to do these review pages, 24, 25 for now, and then we're going to take a look at trigonometry review. Okay, so these reviews, you might have to look back over the last couple days of work. All right.